Hello, and welcome to Pilgrammed Math, where today I'll be exploring a fundamental question in Pilgrim. The topic for today is, what is the complete Pilgrammed damage formula? Part 2. Now, in the last video, we mentioned that the formula goes something like this, and we solved the defense part by plotting graphs, finding the percentage of defense left after applying piercing, and drawing the correlation that the new defense value is just original defense multiplied by 1 minus piercing. So now, we move on to the damage taken part. To kick us off, we must first realize that our formula must include the terms 1 minus t, where t is the original damage taken, and p, which is piercing. We will first find how piercing changes with damage taken. So let's use the graph we plotted for Granny from last time, where piercing is 15%. The formula is 0.16666 repeating x minus 4.48. Since we need 2 data points to get a slope, let's go back to Granny, but this time with 25 piercing instead. Okay, we're back. This time I'm going to be using Blood Twin because it has 25% piercing, and I'm going to be using Relentless and a legendary one so I can get 2 distinct data points. Okay, let's go in. Okay, Granny is here. So my 39.6 damage becomes 24.46, and my 32.4 damage becomes, okay, damn it, crit, 19.22. Okay, let's go plot the graph. So after plotting down the values and finding the equation of straight line, we get this equation. Now that we have 2 equations of straight line, let's plot the graph of how an enemy's new damage taken changes with piercing. Remember to only consider the slope of the equations as they correspond to the damage taken of the enemy, which we're trying to measure. Since we used 15% piercing and 25% piercing, we have to match them to their respective numbers, which are 0.71666 repeating and 0.727777 repeating. Let's put this formula on the side for now. Notice that we get a formula where 0.7 is our y-intercept, and it just so happens that Granny's damage taken is also 0.7, which is 70%. Let's run with the hypothesis that the y-intercept is our original damage taken for now, which we will call t. Afterwards, let's plot the graph of where the new damage taken is plotted against the original damage taken. As such, we must keep piercing as a constant, let's say 15%. Now, in our last video, we already tested Observatory Dummies' stats and Granny's stats when piercing is at 15%. Hence, we can just use those data points. Do the same thing and we get another formula, which is 0.94444 repeating plus 0.055555 repeating. Now, this is where magic is about to happen. We have 2 forms of the same thing, so with some algebra, we can find the complete formula for the damage taken part. Let's extract both of our equations and form an equality. Firstly, change 0.11 repeating to a new variable, q. Our goal is to express q in terms of 1 minus t. Deduct t on both sides of the equation. Notice that the coefficient of t is the same as the constant term on the left-hand side, so factorize it out. Rewrite 0.55 repeating times negative t plus 1 into 0.55 repeating times 1 minus t. Then divide the equations by p on both sides. Recall that we set piercing as 15%. Hence divide both sides by 0.15. Therefore, q equals 0.37037 repeating times 1 minus t. Recall the damage formula. T times b minus d. D can be rewritten as d times 1 minus p, and t can be rewritten as t plus p times q. Therefore, this should be our damage formula. But due to errors in measurement of data, the calculated number will not line up with our actual output. So let's set it as an unknown and solve for it. Okay, so in this demonstration, I'll be using a Relentless Blood Twin with a base damage of 32.4. This is me showing my loadout, so you know that I'm using absolutely nothing. And I'm going to be testing it on Observatory Dummies. So as you can see, I did 13.61 damage. However, if we look at our statistics, we do 13.62 damage. So which value do we take? The answer is both, but not in the way you would expect. Let this function be our damage formula. Now, plug in the values for T, P, B, and D used in the experiment. Since we have two damage outputs, we need to set two equations. And if we solve for x, we get these two values. Then, take the average of the two values and we get 0.3743. And then, let's round this off to 0.375, and therefore, our formula is this. With this equation out of the way, we can finally move on to simpler topics, like the anomalies of negative defense or damage reduction piercing. Expect more in the future.